Thank you so much for joining us today. I hope everyone is doing well and staying safe. My name is Victoria, and I'm a Senior Business Development Coordinator at 2H Offshore. With many industry events and conferences canceled due to COVID-19, we've put together this series of live webinars to keep our valued clients and colleagues up to date on the latest happenings in the world of riser and conductor engineering. I want to welcome you all to our webinar today entitled MOPU-Supported Platforms, Gateway to Fast-Track Production. Before we get started, I'd like to cover a few important housekeeping items. Firstly, this webinar is being recorded and will be made available to you soon, so please look out for a link to that in your email. Secondly, if you have technical or content-related questions today, please feel free to ask them at any time. You can use the Q&A box that is located on the right-hand side of your screen. At the end of the presentation, we'll go through as many questions as we can, but if you have further questions, feel free to contact our speaker directly after the presentation. And with that, I'm very happy to introduce our speaker today, Ben Andrew. Ben is a director at 2H with 15 years of specialist engineering experience in design, analysis, and delivery of conductor-supported platforms, deepwater production, and drilling riser systems. He has held project management and technical lead roles on projects from concept through to detailed design based out of London, Leiden, Houston, and Kuala Lumpur. With that, I will pass things over to Ben to get us started.
Thank you, Vic. I hope everyone can hear me okay. We're all getting very used to video conferencing at the moment, so this is even less weird than it maybe used to be doing these webinar things. So it's an exciting topic today. I hope you find it interesting. And just to reiterate, if you do have any questions, please do ask throughout with the tool on the side, or do feel free to contact me. My contact details will be at the end of the presentation. So, by way of introduction into the reason behind this topic and what I want to focus on today, in the current world of $40 oil, and let's all hope it stays there or above for the foreseeable future, but it's still a low price, of course, for oil, and that generates a lot more focus on marginal fields, on development extensions rather than greenfield, and on fast-track production to try and cover the outlay and start recovering some of those costs as quickly as possible. Some of the strategies that can be beneficial in making this work are around reducing capital expenditure in order to make a project more viable, but also in terms of having flexibility to be a bit agile as the market evolves or as a reservoir evolves, to avoid future capex expenditure to maintain a field, or to allow you to sort of cut your losses if necessary. For shallow water development specifically, those solutions can include satellite developments, for example, so deploying wellhead platforms tied back to central hubs, where those wellhead platforms are more compact and cheaper to install, but that generate high value. And it can include the use of minimum facilities platforms and normally unmanned installations as part of that. We'll talk a little bit about those in a minute. And then specifically for this presentation, it can include the use of leased MOPUs, mobile offshore production units. These both reduce capex and they also give flexibility. So they really speak to both of those strategies mentioned above. But of course, lease of a MOPU does come at a cost. It cuts your capex, but it comes at a significant OPEX cost. So this does need to be done right to deliver that value, or you end up with a false economy potentially. So getting that MOPU solution right up front is important. So to try and meet those objectives today, I'm going to start by giving just an overview of minimum facility platforms and CSP, conductor supported platform technology. I've actually presented a couple of these slides before, but they serve to give a good base understanding of the sort of technology we're talking about. And then we can move on to what the MOPU brings to that table and how it can add additional flexibility and capex reduction. Once we're clear on all that, I'll talk a little bit about some of the key design considerations in making a MOPU solution work successfully for your development, and then finish with a bit of a case study of where that's been successfully done and some conclusions. And then there'll be time for questions at the end. So let's start by talking why a minimum facilities platform makes sense. And again, it's all around reducing those capex costs and getting early production on stream. So firstly, minimum facilities platforms can reduce our T&I costs. Our strategy for achieving that is often to use a jack-up drilling rig for all operations. It's there on site already, no mob demob costs in getting it there. And if you can keep that installation duration short, that can be a very cost-effective way of installing a wellhead platform or a minimum facilities platform. In some cases, that's not practical or the right decision, but even then you can make sure that you can use a very low spec installation vessel, avoiding real heavy lift facilities, for example. And you can also reduce your transportation payload, so you're using small anchor handling vessels rather than large transportation barges, for example. Secondly, the structures themselves can be small, and that makes them more cost effective. Reduced fabrication tonnage, of course, just a simple price per ton times the weight. But also there's a benefit to being able to use local yards to reduce the distance of transportation by keeping that tonnage down. And for the facilities, it's really about making sure that we are merely fit for the intended purpose. We're not adding too many bells and whistles, too many nice to haves. We're staying very disciplined on delivering just what is needed to realize the value of the development. And then the third pillar, if you like, is early production. So the strategy here for us is generally to deliver a fast track substructure. Some images of that are shown bottom right on the screen there, which can then allow some pre-drilling through that fast track substructure that can be delivered very quickly. And we can use simple standardized design and fabrication techniques in order to do that. That allows the drilling to be progressed and completed, which is quite a time-consuming part of the project, of course. And once that drilling is complete, that can be done in parallel with finishing off the facilities, the topside equipment, and delivering that to allow fast track first oil once the topsides is installed. So those are the objectives and the reasons really for a minimum facility platform. There are an awful lot of different interpretations, though, of a minimum facilities platform. So I think it's useful to be clear what we mean by that. And there's a real scale. On the far left there, you've got freestanding conductors. So that's literally a well on a stick, maybe with a small access platform and basically nothing else. Through to monopiles, where that's maybe strengthened with a small deck for access. And then we get into the more worthwhile platforms, if you like, starting at tripods. An example of that shown bottom left, a very basic tripod wellhead platform, trees, a small davit crane, a VDOT boat landing, bit of room for slick line and so on, and not a lot more. And they might even be retrofit to an existing exploration well, maybe. Topsides not exceeding 60 tons, maybe export via a hose, not a lot more than that. Going beyond that, we get into more of a full-on wellhead platform, which may have more than one deck and provides wellhead access, but also a degree of manifolding and again, export via a riser and a pipeline system and some flow metering. Topsides here may be pushing the 60 to 200 ton range. And then beyond that, we'd get to what we would call a full minimum facilities platform, which would definitely have 3 decks, can process maybe more like 10 to 20,000 barrels a day, provides wellhead access, chemical injection, maybe a bit of process equipment, but we'll come on to that later. Again, multi-phase flow metering, maybe individual well metering, and the top side is more in the 200 to 500 ton range. And then beyond that, you move into full jacket solutions, which can still tick the MFP box, but there may be more in the 2,000 ton topside range at that point. So the solution that 2H likes to use for tripods, wellhead platforms, minimum facilities platforms is the conductor-supported platform solution, which is what I'm showing in those images there. So what do I mean by a conductor-supported platform? Well, we like to use the wells that are inherent to an oil platform as the structural legs of the platform itself. So that basically uses the spare capacity within those conductors to support the platform and the equipment. 3 to 9 wells or legs is quite typical, although there is an option for those two things to not be the same by using dual completion or splitter wells to get more wells for a given number of legs. And those legs may be purely structural or may be well containing. It can vary depending on the number of wells and the number of support conductors required. And below that, you have a substructure. And the key difference here compared to a jacket is it's not a large, battered jacket that runs all the way from the seabed to the topside necessarily. In many cases, it's built up of much smaller, modular, compact substructures that can be easily fabricated, transported, and installed. They may be just a guide template, as shown on the right there, or may extend to a more substantial jacket, a larger jacket, and maybe additional mid-span braces for the deeper waters. Beyond about 70 meters, they may become modular jacket-like structures, but again, they are kept slimline for ease of transportation and installation. And they'd also include all the normal features you would expect around riser and conductor guides, installation aids, access, boat impact protection, etc., that you would anticipate with a jacket. But of course, they come with some limitations, and this will play to the MOPU point in a moment. The big ones really are topside weight and water depth. Anything up to about 400 tons is very doable. As we get beyond 400 tons of topside weight, things start to get more challenging. It can be done, but the benefits of the CSP solution start to be reduced at that point. So you can see how if you need quite large facilities manifests, that starts to become a challenge for a conductor-supported platform. Similarly, in water depth, 55 meters is the sort of conventional limit for a conductor-supported platform, although the technology can be extended to 70 meters and even up towards 120 meters. But again, you start to impact the commercial benefits of the CSP technology. Fatigue-wise, it's a fairly obvious scale from benign on one end to severe on the right. CSPs are best suited to fairly benign environment in terms of fatigue. They can work in extreme environments, hurricanes and the like, but they do need to have a reasonably benign fatigue loading environment. And then in terms of wells, as I've said before, anything from 3 upwards, really, depending on the use of splitter wells. And in terms of equipment, I've mentioned the manifest needs to be really fairly limited. This is sort of the upper end of a typical conductor-supported platform equipment manifest. We have solar panels for electrical with additional diesel generators as backup and battery systems. We have the usual sort of safety equipment on there and dual access and so on. In terms of process facilities, not a lot other than flow metering, manifolding, and remote shutdown and communications systems. Beyond that, there's not a lot of sort of process equipment normally that would be put on a conductor-supported platform like that. And again, that can limit their usability. So this brings us to the main purpose of the presentation, which is to talk about where the MOPU can fit in to support this system. As I've said, in order to be cost effective, MFPs and CSPs do have some limitations, particularly in terms of their topside equipment weight and their water depth. But a MOPU platform can be delivered quite quickly alongside a lightweight wellhead platform, further accelerating first oil, but also reducing the fabrication size and installation complexity of that wellhead platform and extending its range of water depths in which it can work, and we'll see that in a minute. It can also deliver a further reduction in installation and decommissioning costs if that wellhead platform is smaller in terms of substructure, in terms of SOP sides, then decommissioning of that platform will be cheaper, and the rest of the equipment is all on the MOPU itself, which can demob from the site and be decommissioned or repurposed and redeployed onshore. If extended well testing is needed, rather than doing that from an expensive drilling rig, the MOPU itself can continue to do some of the extended well testing and then transition to production, which can help to save on rig day rates. And again, because the MOPU can essentially disconnect and leave relatively easily, you can accommodate much more flexible development scales and durations. If the wells prove less productive, it can depart sooner. If they prove more productive, then things are potentially expandable with additional wells and so on in order to keep production rates high. And everything that's done on the MOPU can, of course, be fitted out in parallel with everything else at the dockside and shipped out as one piece without additional transportation, which can help manage costs as well. So this really works when you have projects with short production durations, is one example. This is where the CapEx and the DECEX, the decommissioning costs, become much more critical, because those costs are fixed, but they are amortized over a much shorter period if your production duration is short. Similarly, if reserves are uncertain, so you don't really know if your production durations are going to be short or long, then it can make sense to go in with a low capex solution with a MOPU, and it can then stay longer if it needs to in order to keep producing. So you get that flexibility based on production, but also based on oil price movements and volatility and so on. Often wellhead platforms and minimum facilities, normally unmanned installations and so on, are deployed as an extension on a brownfield site. So you may already have a fairly significant, substantial hub structure with processing, either offshore or adjacent onshore. But if you don't have that, or if that has no insufficient capacity, then having a MOPU can solve that problem as well, because you can put a lot more facilities on board that MOPU in order to support the wellhead platform, with that equipment not having to be placed on the wellhead platform itself. Similarly, if the well architecture is more complex, for example, you need high power consumption for ESPs, or you need a rather substantial chemical injection spread due to the production profiles, then having that MOPU opens up those opportunities, because you've got somewhere else to put that equipment. That equipment does not need to be immediately adjacent to the wells. It does not need to be immediately on the same platform. It can be located on the MOPU. Likewise, if some of those aspects are not needed until later life, they can be brought on later and installed on the MOPU more easily, perhaps, than they could be on a platform, and the platform's not oversized in the event they're not called upon. So those are the sort of projects where a MOPU can really add value to the wellhead platform solution. And I've mentioned volatile market conditions and the benefits of reduced capex. So to put some figures on that, and it's difficult because it's very field and location dependent. But a typical example, you might expect to save maybe 3 to 4 million like for like versus the equivalent conductor supported platform. That isn't an immense saving when you bear in mind the cost of renting that MOPU. But it is still a significant percentage reduction on the upfront capex. And when you bear in mind that MOPU may be supporting quite a lot of additional equipment that might make a CSP unfeasible, if you compare it against a full jacket solution, that reduction in capex is much more substantial, although very dependent on the exact situation. So the reductions in capex are significant. And you also get that quick delivery and deployment. You can be on stream in a relatively short period, 4 to 6 months, say, to have a system on stream with a MOPU-supported wellhead platform. And then that OPEX can be somewhat managed dynamically. That MOPU can stay and go, can be retendered and swapped out throughout the life of the field if appropriate, in order to keep that competitive, or it can be transitioned to some other facility. So I showed this slide earlier around the limitations of the CSP product range. And the key aspect here is if you bring in a MOPU, essentially the change is like this. So the top two there are going from lots of red and orange, where there's challenges around large equipment manifests and large water depths, to being largely yellow and green, because the platform itself is partly supported, making the water depth less of a problem. And the topside weight is managed because equipment can be relocated to the MOPU, simplifying the design of the platform itself. It doesn't really affect the fatigue. That still needs to be reasonably benign in terms of fatigue environment, and doesn't really affect the number of wells either. A large number of wells can still be supported. So how do we go about making a MOPU-supported system successful? Well, one of the key decisions that needs to be made early on in proceedings is whether or not you need that system to freestand with the MOPU not present. The simplest in terms of design is to not worry about freestanding and have the thing permanently supported by a MOPU. The risk with doing that is if you do require at some point down the line to reallocate the MOPU, swap out the MOPU, then there can be significant costs associated with handling a platform in that situation when that platform was not designed to freestand. And those costs can be considerable, and I'll give an example of where that's been a challenge in a moment. If you do go down that route, though, essentially what you've got is a small well bay that's integrated on the MOPU, and then the wells themselves are just freestanding wells supported by that deck. They may need some additional bracing in deeper water, and depending on the diameter of the conductors, but they're not taking any of the topside weight, and the fatigue performance can be managed. The other option is to reduce the substructures even further, is actually to tension those wells through small tensioning systems mounted on the platform deck. And then those loads are reacted back into the MOPU. So you do get some additional options and further reductions in substructures if you can live without a freestanding solution, but it comes with a certain amount of risk due to change down the line. Conversely, if you do design for the freestanding option, then you're essentially designing a minimum platform that can freestand without support. That will generally mean additional structures or bracings are needed. It will tend to mean that you want to be at 36-inch conductors. In shallower water, 30-inch can maybe be made to work because those conductors are now supporting the platform. It also means you need to be extra careful to have a small equipment manifest on the platform and get that equipment on the MOPU, because otherwise you're heading back towards a full CSP solution and some of the benefits of the MOPU start to disappear. So that strategy over do you or do you not need the system to freestand and how you will handle the equipment manifest is key that needs to be defined early in the project to ensure a successful delivery and that you actually deliver on the value that you're targeting through the MOPU. The second thing is the actual MOPU or MODU interface, how that deck is supported primarily. Key here can be things like the height of the deck. If you have, for example, a barge acting as the MOPU with a very shallow deck height, then you're having to cantilever that deck off without a lot of vertical support, which can limit what can be done. In particular, may require the pile to take a lot of the load. If the deck is higher, then that becomes easier. But whichever solution you go down, a certain number of modifications to that deck are likely to be required. They may be as simple as welding on a pad eye or two. They may involve a certain amount of local structural stiffening and reinforcement on the platform, in which case there may be associated reclassification work due to the modifications to the hull of the vessel. And finally, we need to think about the installation. Will it be installed by, for example, cranes on that MOPU? Will it be installed by the drilling rig as part of the drilling operation? That would normally be our base case approach. Or will it be handled by a dedicated installation vessel? I mentioned an example where things can go wrong without making those decisions, and that's what this slide's about. This was a platform that was about 65 meters water depth in Malaysia. It had 4 slots, 36-inch conductors, and it had the well bay supported on the MOPU with the wells freestanding. So in this example, the entire structure, shown in the picture top right there, was supported by the MOPU, and the wells themselves just stood within that. So these wells were not supporting the weight, or not designed to support the weight of the whole platform. So they went down the no freestanding platform route. During the field life, the decision was made to remove that MOPU as a result, basically, of the field proving to be more fruitful, and they wanted to keep production going. But there was no original design to freestand that top side on those conductors. And you can see that on the right here. They were very long freestanding conductors all the way up to the deck. So if you disconnected from the MOPU here, these conductors would actually buckle under the vertical load. Clamp bracings had to be installed in order to allow for some temporary freestanding. And even then, the fatigue performance was pretty atrocious. So the duration during which it could freestand was very short. So ultimately, the solution here was an entire additional jacket and support structure in order to support that. And of course, at this point, the costs of that are very substantial. And had this all been considered early on, a few small structures around here would have meant that it could have been left freestanding for a much longer period, rather than having to bring in this entire retrofit system. So that's why some of these decisions are important. I mentioned earlier as well about the facilities side of things. It varies, of course, application by application, but this table here just gives an example of what sort of solutions would be on an MFP in terms of the facilities equipment versus what would be on a MOPU. And shown in green are the things that you can essentially win with a MOPU solution as opposed to an MFP without having to go to a fully expensive jacket with all the increased capex costs that would entail. So examples are around expanding your well duties to not just production but injection and gas lift and so on. That can be done by putting the associated equipment, water injection pumps and so on the MOPU. Pig systems, generally we just have a pig valve on an MFP. Pig launchers and receivers can be deployed on the MOPU. In terms of test separators, so starting to move into slightly more process facilities, you can have a test separator on a MOPU. We would generally avoid separators on an MFP due to weight. Venting, you may be able to put a flare on a MOPU depending on how much footprint area you've got and where your accommodation is and so on. Chemical injection on an MFP, we would generally do limited chemical injection, again due to weight and footprint requirements. But if your wells require much more substantial chemical injection or a variety of chemicals throughout their design life, then you can get a full spread on a MOPU. And then in terms of accommodation and control rooms and so on, the most we generally have on an MFP is a refuge, and escape routes would be a mixture of stairs and ladders. But on a MOPU, you can have a full control room, a temporary accommodation, primary and secondary stairs for escape routes and so on, and more enhanced hydrocarbon detection as a result. And finally, in terms of power generation, for an MFP, we generally limit this to a relatively low wattage solar and maybe portable diesel electric generators, or alternatively remote supplied umbilicals with transformers. But for a MOPU, you can have a full diesel generator, again, due to footprint and diesel supply and so on. So those are the additional facilities you can win with a MOPU. And although the capex saving between a direct comparison between an MFP and a MOPU is relatively modest at maybe 3 to 4 million, if you factor these additional functions in, you start comparing a MOPU with a jacket, and then you see a much bigger benefit. A few images here of just real stuff. Top left there, you've got an example of a mid-span brace structure being skidded out from the drill rig, ready for deployment. Top right, you've got examples of hull interfaces in terms of, sort of socketed pad eyes welded onto the MOPU hull. Bottom left there, you've got an example of that same brace held in the MODU's Texas deck during piling operations. And bottom right there, you actually see a freestanding system being handed over. So on the right or the far side there, you have the drilling rig with what it was using to support the platform. It's now jacked down. So this is now a freestanding wellhead platform. And over here is the MOPU that has come in and that will connect in to this to support it for the rest of its life. So that's been supported by the drilling vessel during drilling and then handed over to the MOPU for a brief period of freestanding. So I'm going to finish with an example project of where this has been done successfully, and then we'll have time for some questions. This is a project where the desire was to essentially deliver some minimal structures and crack on with the drilling operation. So it's the one I showed in that previous picture. A very minimal wellhead platform was installed from a MOPU with very limited structures. The wells were drilled and completed from that MOPU, and it was designed to freestand for 3 to 6 months if needed to de-risk the vessel schedules. In reality, it wasn't required to freestand for that long. The MOPU turned up on time, as you can see in that picture on the right. That's the handshake. You can see there, again, the MOPU with its Texas deck arrangement supporting that temporarily. This would be disconnected, jacked down and depart, and then the MOPU connection to the top side would be made up. And of course, further drilling can be done subsequent to that. And this is an idea of the structure sizes that we were dealing with here. This was a sort of 60-meter water depth case with 11 well slots of 36-inch conductors with fatigue optimized connectors on. But they were very compact structures in terms of just a guide base. This was non-structural at the seabed, a structural mid-span brace to react loads between the conductors at mid-water depth, and a small topside deck braced back at the top with very little equipment on it. These clamps were made up by divers. They were kept at a depth that diver access was feasible, and this whole system was delivered within under 4 months. So to conclude on all that, MOPU-supported wellhead platforms can successfully deliver fast track both for drilling operations and through to first oil. They're particularly well suited for applications where the project is cash or capital constrained, and they can deliver savings overall depending on the project duration. And that makes them good for developments with uncertain reserves or in volatile markets, and for short-lived fields where you're not going to be producing for decades. To make it a success and deliver on that value, it's very important to fully understand the MOPU and the rig, and not just concentrate on one aspect. Decisions around the supported and the freestanding scenarios are important, as illustrated by our example earlier. And optimizing those delivery schedules, focus on getting the drilling done so that when the equipment is delivered, you're ready for first oil, keeping that all off the critical path, and using genuinely minimal structures and rig installation is often it's our preferred solution to deliver on that. Make sure the engineering is smart so that you don't waste steel on unnecessarily large structures. Keep things optimized, keep things installable and effective for the task. And where possible, use standard approaches and components, but again, bespoke design for the specific application, because no two MOPUs, no two rigs, no two well architectures are ever quite the same. So while standardization is good, bespoke design is crucial to success. So, and that's it for my presentation. Very open to questions. I imagine Vic may have some.
Thank you so much, Ben. Yeah, we have some questions that have come in, so I will get started asking those. Let's see. The first question: what would the turnaround time be for a brand new tripod CSP system?
So if it can be, so we frequently deliver in less than 9 months, but that 9 months is normally driven by conductor delivery, which can be 7 months plus, maybe for 36-inch conductors with fatigue premium connectors. That depends on the current market. Sometimes you can get them quicker, and sometimes they may be in stock, and sometimes 30-inch may work, which can be done much quicker. And the second thing it's constrained by is equipment delivery, for which the lead time can be of that order. If all one's talking about is delivering a small tripod platform or retrofit system in relatively shallow water with limited equipment manifest, then 4 months is achievable. So that's a pretty wide range of durations, but it's really driven by the connector supply and the facilities supply.
Okay, great. Next question: when would you typically use a MOPU compared to a minimum facility platform or jacket? What is the cost break point to go one way or the other?
Yeah, so I think it's very hard to answer that question in absolute terms. The cost break point is roughly we would probably say 2 to 3 years, but it very much depends on the particular operator's appetite for capex. How much value they see in deferring cost into opex. It depends on the amount of equipment needed, and if you're comparing between an expensive jacket, maybe 20 million or so, compared to a MOPU, or whether you're comparing to more of a CSP type solution, which is already quite a cost-effective method of developing a field. This is not a good solution, I would argue, for sort of 5+ years, because the cost of the MOPU lease will dramatically exceed the capex, and it's hard to imagine that saving being justified for the deferment of payment.
Okay, kind of a follow-on question, I guess, from this. How long can a MOPU stay in place?
So it can stay in place essentially as long as it's classified to stay in place. I think the MOPU is subject to classification in terms of the modifications to it as well, and would need periodic reclassification, typically, or recertification at certain increments throughout its life. So that will depend on the particular classification of the platform. It's not constrained by the production operation or supporting the platform.
Okay, next question is, are there any modifications required on the rig and the impact on class of the hull?
Yeah, so again, I think I just touched on that one. We try and keep the modifications as small as possible for essentially that reason. It's likely limited to pad eyes for attachment, and maybe a local bulkhead stiffening around those regions. Again, the load coming from the platform itself onto the rig is not normally driving the rig's overall design. It's more around the local connection point on the hull. And what level of work is done there. In some cases, the platform already has pad eyes mounted there, and if we can use them, we will.
Okay, next question is, in your experience, does the CSP work for gas wells?
Yes, we can use we can produce gas as well as oil. We generally, most platforms we've installed have been for oil production. And there are some differences on the facilities side. That might be a good question to take to our facilities experts offline, actually. So I'm not sure who asked that question, but it might be good, Vic, to follow up on that one afterwards.
Yeah, we can get you guys in touch. Okay, what's next? Where are these systems typically being used the most, I guess?
Yep, so there's a number of these deployed in sort of Southeast Asia. The couple of examples I actually presented in this slide pack were from Southeast Asia. There's also a few in sort of West Africa regions. Basically, though, they can be deployed anywhere with a fairly mild fatigue environment. Conductor-supported platforms are very popular. There's a lot of them in the Middle East as well. Again, a fairly benign fatigue environment, reasonably shallow water. And the MOPU system would be a viable solution there as well. I guess with the Middle East, the production maybe tends to be a little bit more reliable, and therefore the design lives tend to be longer, and therefore the economics might point towards more of an MFP CSP solution rather than a MOPU solution. As mentioned earlier, any region that is reasonably benign in terms of fatigue, and that has particularly if you've got poor confidence in the reservoir, those are excellent candidates for this.
Okay, next question. Are divers or ROVs required for the structure's installation?
It varies, again, which that's often the answer, which isn't very helpful. But if we have substructures, we generally try and ensure that they are within air dive depths, so say 25 meters below waterline, in order that we can get away with fairly low cost diving activities. If we have to go deeper than that, we need a template, for example. We try and do that with grouted connections rather than clamped to avoid the need for divers. And those grouted connections can either be pre-rigged with stingers to avoid ROVs, or can use ROVs for the grouting operations.
Okay, thanks. Another one, is there an opportunity to recycle unwanted jackups as MOPUs, or is that too heavy-handed to be a viable solution?
So I think it depends on how cheap you can get the jackup, really. I don't think it's necessarily too heavy-handed. In many ways, having a larger MOPU there, a larger substructure or superstructure to connect to is beneficial. You can support more of the weight of the system from the MOPU rather than on the conductors, which can be beneficial. So that's okay. I guess, yeah, it depends entirely on the price that you can get that MODU at. In the current market, I imagine they're going fairly cheap.
Okay, I think this will be our last question. Could such a system be used for tieback wells?
Okay, yeah, that's a good one. Yes, it can be. Tieback wells we generally wouldn't want to use as the structural conductors on the platform. So, we have these support conductors. A conventional CSP, those support conductors are themselves wells, but there's no reason they need to be. They can be a mixture of wells and support conductors. And as long as you've got those support conductors in place, you could have additional tieback wells installed inside. So, for example, you could have say a 3 or 4 leg pile-supported platform where maybe 1 or 2 of those are being used for wells, but you've maybe got a couple of tieback wells run internally and either tensioned off the deck or just supported and guided as necessary, because they may be smaller diameter, say 24-inch tieback wells that maybe can't free span or freestand all the way from the seabed to the production deck. So yes, you absolutely can use tieback wells on these, but generally not as the structural members. You will generally need structural members as well, at least if you're going to freestand.
Gotcha. And I'm just going to squeeze in one more question. For conductors at the freestanding type condition, what will be the minimum fatigue life safety factor?
So we generally, at least initially, work to a safety factor of 10 for components on these platforms. That's on the basis that they are, in terms of the conductors themselves, are structural members, not particularly redundant members, hard to inspect and repair. So that generally points you towards a safety factor of 10. As with all things, different codes have slightly different things to say. And it can be possible in certain circumstances to argue for a reduced safety factor of 5 for some of the members, and for anything where we've got good redundancy, maybe even for 3. But we start at 10 as our sort of starting point for our safety factors, because these are failure critical components.
Okay, perfect. Well, thank you so much, Ben, for all the information provided today. This is all the time that we have for today, but as we mentioned earlier, if we didn't get your question, or if you think of more questions in the coming days, you can contact Ben directly using these details provided here. I want to thank everyone for your time and participation. We hope you found this useful and will join us for more webinars in this series happening every 2 weeks during our time at home. You can check out the 2H website and LinkedIn for more details and to sign up. And again, please look out for the recording of the webinar in your email in the next 24 hours. And we hope everyone enjoys the rest of your day. And thank you.
Thank you, Vic. Thank you, everybody, for listening.